Okay, so the Pythagorean theorem is the sum of the square of the length of the legs of a right triangle is equal to the square of the hypotenuse. The hypotenuse will be found opposite the right angle. Now in general, in any triangle, the hypotenuse is going to be opposite the largest angle. In a right triangle, the largest angle is going to be the right angle. So the hypotenuse is always the side opposite the right angle. Okay, now we do have a shortcut, and this is your first vocabulary term. Although it's not clear to me that we're going to have a vocab quiz for chapter 8.
Yes.
They're easy.
Bless you. Okay, so sometimes we have certain relationships between the sides of the triangles that allow us to know our answer, to know the lengths of the sides or the lengths of the hypotenuse without having to go through the whole a squared plus b squared equals c squared process. We call those particular triangles Pythagorean triples. Now it's just something that either you learn it or you don't. In other words, even if you're given 3 and 4 as your sides of the triangle, you can use the Pythagorean theorem to find out that the hypotenuse is 5. But if you recognize that 3, 4, 5 is one of the Pythagorean triples, if you're given a problem and you're told that 2 of the sides are 3 and 4, you automatically know that the third side is 5. And you don't have to go through the whole Pythagorean theorem process and then solving and taking the square root. So these are the 4 most common examples of Pythagorean triples. And they will pop up from time to time on homework, on quizzes, and on the EOC. It could pop up. Now this just means, Riley, that if I take 7 squared and I add it to 24 squared, that's going to give me 25 squared. So 7 squared is 49, and 24 squared is 576. And that's going to equal 625. So if you don't have to know these, but those of you who learn them, will not have to go through the trouble of doing the Pythagorean theorem. Yes, sir?
What do you do after 625?
What do you mean?
You said the hypotenuse is 25.
Right. That's 25 squared. The Pythagorean theorem is a squared plus b squared equals c squared. So if I tell you that these are the length of the 2 of the sides of the triangle, and do 7 squared, which is 49, plus 24 squared, which is 529, both sides of 10 is 6, which is c squared. I add these 2 together, gives me 625 is equal to c squared. But I don't want c squared, I want c. So in order to get the answer, what do I have to do to this in order to get the answer? What? I don't divide it.
Unsquare it.
Yes, you unsquare it, which is otherwise called taking the square root.
Okay.
So I take the square root of both sides. So the square root of c squared is c. And then this is going to be the square root of 625. I plug that into my calculator, and I get 25. That's how we use the Pythagorean theorems. But if you know these relationships, you don't have to go through all this. You just say, oh, one side is 7, the second side is 24, third side is 25. Save yourself that work. And remember, the more work you do, the more likely it is that you're going to make a mistake. So if you learn the Pythagorean triples, fewer chances to make a mistake. You can always double check your work by using the Pythagorean theorem, but these will save you time. All right, so this is how we find the length of the hypotenuse. Okay. Okay, now you're not always going to be asked to find the hypotenuse. Sometimes you're going to be asked to find one of the legs of the triangle. So we start the same way. We start by writing the Pythagorean theorem. Now the difference is, instead of finding C, we're going to be finding either A or B. Now, it doesn't matter which side you pick as A and which side you pick as B. So you could say either x squared plus 8 squared equals 20 squared, or you could say 8 squared plus x squared equals 20 squared. What property of math allows you to do that? Raise your hand if you know. If you don't know, I'm going to just
Oh yeah.
Justin, what property of math tells me that when I'm adding, the order of my values doesn't matter? Justin, do you know? Thank you. Riley, do you know? Can you help him? No?
Oh.
Anna, do you know? Carla, do you know? No. Alan, do you know? No. Micaiah? No. Naya? Commutative property. In addition and multiplication, order doesn't matter. Okay, so how do we go about solving this? First thing we're going to do is we're going to square the numbers that we do know. So we have that x squared, or if you like, a squared, doesn't matter, plus 8 squared, which is 64, is equal to 20 squared, or 400. Now we're just going to solve for A. So we're going to subtract 64 from each side. So we get that A squared is equal to 336. Now, the book, and probably the EOC, doesn't want a decimal answer. Now we all know what to do. We all know that we're going to have the square root of 336. Now for some reason the book says that we don't want the decimal equivalent. The reason we don't want the decimal equivalent is because it's just that. It's an equivalent, it's not the exact answer. A decimal does not give you the exact answer unless it's a perfect square. So what we have to do instead is we have to simplify the square root of 336. So what we want to do is we have to find factors. Anybody understand what a factor is? Not multiples. Factors and multiples are... That's right. Factors are two numbers multiplied together equal that number. So in other words, the factors of 8 are 1 and 8, because 1 times 8 is 8, and 2 and 4, because 2 times 4 is 8. So what we need is we need numbers that multiplied together add up to 336. Now, since I don't want this to be a lesson on how to factor, what you would look for if you were doing this on your own is you're going to look for not just the factors of the number, but you want a particular factor. And those are the factors, the largest factor, that gives you what's called a perfect square. Is there anybody who does not know what a perfect square is? Jonathan, you don't know? Oh, I want Alan to tell me. What's a perfect square? Tyler? No. Nothing to do with perfect square. Nothing to do with the shape square. Joe, perfect square.
Is it a number that can be equally divided by something?
That's right. A perfect square is a number that, when you take its square root, you get a whole number. 4, 9, 16, 25. All those numbers, you take the square root, you get a whole number. Okay, so what we would be looking for is the largest one of the factors of 336 that is a perfect square. And I will tell you that what we get is the square root of 16 times the square root of 21. The square root of 16, we can simplify. What is the square root of 16? The square root of 16 is 4. We don't know, we can't simplify 21, so we leave it alone. So the answer that the book is looking for is this. So if you don't know how to factor something, yes, Ryan?
How would we break it?
You mean on the EFC?
Yeah.
It's probably going to be a multiple choice question.
Can't you just see square by b squared plus s squared?
Hold on, could you just
That's
repeat
what we
that
did.
last part again? 'Cause I did
That's
not.
what we did?
Yeah. Hold on a second. Look. A squared plus b squared equals c squared.
Right?
So I figured out what a squared, here's b squared and c squared. And then I subtracted b squared.
I guess you could, okay, I just.
So, X would equal.
What? Okay. All right. So in addition to the Pythagorean theorem, we have the converse of the Pythagorean theorem. What does it mean to have the converse of a statement? Not the opposite. What would be the opposite, Dylan? The inverse is the opposite. The converse is the reverse. So the Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. The converse says if you have a squared plus b squared equals c squared, then that triangle is a right triangle. Again, the Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. The converse starts off by telling you the length of the three sides and then asking you, is that a right triangle? So in other words, it's going to give you, for example, tell you that the triangle has lengths of 85, 84, and 13. 85, 84, and 13. And it's going to ask you, is that a right triangle? Well, how do we know? Well, we have to set it up in the Pythagorean theorem and see if it makes sense. So what we need, the only one we need to know is where does the hypotenuse go? Well, which is the hypotenuse of these three values? 85. So I say 13 squared plus 84 squared is equal to 85 squared. I plug each of those three numbers into my calculator, and I see if it makes sense. So 13 squared is 169, and 84 squared is 7,056, and 85 squared is 7,225. Now I add these two numbers together, 169 plus 7,056, and it gives me 7,225. Since 7,225 equals 7,225, I can say that yes, a triangle with these three sides is a right triangle.
We did this in eighth grade. Oh, that's like 5 years.
Eighth grade,
Well, I mean,
Okay, does anybody have any questions?